we see this, we have a vehicle 1, ID 1 is A, B, C on lane C, vehicle 3 is on lane D. So traffic analysis, we have vehicle 1 lane C, vehicle 3 lane D. Hi, welcome to this video. This is Sergio, and today we're going to see how to build a tracking system that also integrates a database so that we can store our information. This is very important because finally we are switching from what is a demo solution. Everything that you see online mostly are demo solutions where there is some tracking, counting of objects done with camera that works or just a few seconds of video. The information is displayed on the screen, but there is no real structure behind this. There is no backend, and that's just a demo, not a real world project. I've also shared many of these videos, and today we're going to get more into this, not only today, also in next videos. And why is this important? Because real system require data retention, so you need data for everything that you want. If you want reports, if you want later to use the information, but also if you want to build a structure for the automation. When you have data on a database, you can build APIs, you can put alerts, you can build dashboards, and so on, and build the logic of the system. And also with the structure, then you can scale your solution. When you build just a Python code that can run on a very short video, that cannot do much. But when you have a database, you have a more solid structure, then later you can have longer run times. If the project needs to run for hours, days, weeks, months, and so on, you can do this because all the data is stored and that stays there. Even if the system stops running, even if there is some blackout and so on, when you process the video, you have the information. To show this example today, I'm going to build this on this specific video footage that I found. We are going to specifically select different lanes right here. Let's suppose that we want to track the vehicles and understand on which lanes the vehicle are passing. So we will select 7 different lanes right here that I'm drawing now. When the vehicle crosses this lane, then we can store this information in the database. What can we do with this information? With such information, we can create a detailed report on where the vehicle was on what specific time. We can create detailed report on dwell time of the vehicle, max length queue, how many vehicles on a certain hour, and so on. So once we have this information, later we can extract it as we want. And of course, this is just a sample right here that I'm showing you. You can apply the same system on any type of AI vision solution, whether you are tracking any type of objects from a conveyor belt, if you are detecting defects, if you are tracking, counting people, if you are detecting size of objects, anything, the concept is similar. You need to take the information that you see on the screen and then save everything into the database. Now, from scratch, we're going to see fast how to track the different vehicles, so object detection, object tracking, and later we'll focus a bit more into storing this information into the database. Now I'm going to start coding. I'm going to be very, very fast and using also the Copilot on the tracking and detection part, because this is not the main focus, but I also want to show you this because I want to show you everything from scratch so that you have a better understanding on where we take the information and how we store it. So we start first of all to load the video, so cap equals cv2.video capture. We have traffic camera mp4. Now let's show everything on the screen. So we make a while loop, we get the frame, and then we show the frame on the screen, and then cap release and cv2 destroy all the windows. Let's run this. Pretty much now we are running with Python the video. Now we need to perform detection, which means we need to detect the vehicle. So we import an object detector from engine.object detection. We're going to import object detection. Now we load the detection model. Object detection is object detection, and then we have already the model saved here, and now we can detect the objects right here. So detect objects and display bounding boxes. Right here we have bounding boxes, class ID scores, od.detect, frame, image size 640, everything as standard. Let's not get more into that. Now we're getting the coordinates of the detection. Let's now display everything on the screen. For bounding box, class ID score, in bounding boxes, class ID scores, we're going to loop through all of them and then we are now getting the position of the rectangle and display everything. You see, now we have the detection. We see cars, trucks, buses, and so on. Detection is perfect. No, it's not. The small vehicles are not properly detected, and so on. Since our goal in this sample right here is not doing any sort of optimization, but we're focusing on the database part, and specifically where vehicles are pretty much visible here on the different lanes, we now move further and we proceed with object tracking. Before moving further, I want to let you know that all the sources that I'm using here are part of the AI Vision Academy, which is a membership and a community where you can learn how to build AI vision solutions. There are many courses from the fundamentals to build more advanced solutions, and also there is community support where you can ask questions about your project and you can interact with other members. Link down below in the description. Now, how to perform object tracking? To have object tracking, we need to add an algorithm to the detection. You should be familiar, hopefully, with object tracking. If you don't know the difference, when we detect the objects, we are just doing detection on a frame after a frame. Even if it's a video, it's frame after frame. Object tracking will allow us to identify each vehicle with a univocal ID, and then we can follow them through space. So we know it's the same vehicle and we don't count that twice. So now we load the tracking algorithm from engine.object tracking. We import object tracking, multi-object tracking, and then we load the tracker, and right here MOT, multi-object tracking, and now we load a specific tracker. We load OSIS sort algorithm. If you're wondering about all of this that I'm importing, it is a custom implementation that I personally created that uses YOLO and uses different tracking algorithms and makes everything user-friendly, even beginner-friendly if you want to build such projects, and all these sources are part of the academy. Now we go on. After we have the detection right here, I remove the displaying of the detection, and instead now we perform object tracking, update tracker, bounding box IDs, tracker, update bounding boxes, core class IDs, and frame. And now let's loop through everything that we get from the tracker. Now the main difference that you see right here is that we have numbers over the vehicles. So we have a univocal ID. We see, for example, 16 car, now 84, not performing perfectly so far. Let's maybe adjust this a bit. So the detection is not working great, as you see, and that's why we're getting not good tracking, we're losing the IDs. My assumption is that the YOLO standard is not trained on such CCTV cameras data from top camera where the vehicles are like very low. So I'm now going to change the model with a trained model that I have on some vehicle dataset. I made some very simple adjustment where relatively simple, because I have a trained model of around thousands and thousands of vehicles. So I have a better model, but also increase the image size that the YOLO model processes so that it can get also smaller objects. And the accuracy difference now, it's quite big. You see also now a lot of vehicles are very well tracked, despite they are very, very small and they are tracked on a big area. So we have object tracking that was pretty fast because we have everything pre-built already. I was just calling all the different libraries. I have the model and so on. Now, what do we want to do? Now we want to take information, store the information of these vehicles. What do we need to store? We have the IDs. So you see on each vehicle there is a number. And what we want to do is when they cross a specific area, which we call ROI or region of interest, we want to take some information. It could be the ID, it could be a timestamp, so at what time that vehicle was there. Then we could take the class, if our model is also telling the class whether it's a truck, a car, or the different class that you want to. Based on the country, the vehicle class will be different. The specific ROI where the vehicle is, so if we have different lanes, we might have lane A, B, C, D, and so on. So we can take that lane. You might want to store a picture. You can save anything that is useful for your project. In this case, we're going to take the vehicle ID, the lane, and the timestamp, because that's pretty much now good for a sample. How can we move further with this? Now we have 7 different lanes. You see, we can say lane A, this one, B, C, D, E, FG. So when the vehicle is crossing inside the specific lane, we save that vehicle on the database. Okay, we say this vehicle 922 is on lane F. Vehicle, I see 979, it's in the middle, so D and E. 982, vehicle F, and we can get all of these. Let's now import and implement the database. Now, before importing the database, let's select the different lanes. To do this, we can save a picture, then with a software, could be a video editing software like even Paint could be good for this. We can get the coordinates. When we use Paint or any image editing software, when we go with the mouse on a specific location on the bottom left, we see the coordinates. We're going to take all these points, so 1, 2, 3, 4 for each location, so we can create different polygons. So I manually now selected all the different polygons, so I have 4 points for each lane, which will represent on the space the location of the lane, and then I also created a label name, so to each lane we're going to give a name. So we say first lane is lane A, lane B, lane C, as I showed you before, and so on. Now, to make sure that everything is correct, and of course, to have this visual, let's display the lane location on the screen. And we can do this just after we perform the object tracking and detection. We can say draw lanes. What we're going to do, we're simply going to loop through the different polygons. So for lane in lanes, and on each one we draw a polygon. As simple as that. We're now drawing here the lanes. So you see in yellow we have the different lanes. Let me cut a bit the last part of the screen so that we can see things better. Now we have the lane location and we have the vehicles. Everything is now very well visible. We want to intercept when a vehicle is crossing inside a specific lane. When a vehicle is there, then we save it into the database. Now, before saving into the database, we need to get the information because saving into the database is the easiest part because we put a single line and it will just save all the information that we want into the database. What we need to work a bit more on is to understanding the location of each vehicle. Now, step by step, here we loop through the vehicles. We get the rectangle of the vehicles. We show the information of the vehicle. Now, let's remove some information. Let's understand where the vehicle is inside the lane. To do this, we take the center of the vehicle, so CX, CY, center X, center Y of the vehicle. Let's draw a circle around the center point. When each center of the vehicle is inside a polygon, we check, is the vehicle on line A? No. Is on line B? No. Is on line C? Yes. This vehicle is on line C. Then we can store the information on line C on the database for line C and so on. Very basically, how do we do this? We're looping through all the vehicles detected. Now, before saving the information, we want to understand where they are located. So to understand that, we have a point of the tracking of the vehicle. We have a polygon. We can check, is the point inside the polygon? For lane in lanes, again, we loop through this. And then is inside. For this, we have a OpenCV formula, CV2 point polygon test, where the polygon of the lane has inside the point of the polygon. It gives also the possibility to measure the distance from the point to the border of the polygon. We don't need that. We only care if it's inside. Now, to make sure that we are doing this correctly, let's say that if we detect that the vehicle is inside, so if this function gives a value more than 0, it means it's inside. If it's a negative value, it means it's outside. If it's inside, what do? Let's now display on each vehicle the lane. So you see the vehicle crossing and then it will tell you on which lane the vehicle is. So cv2.put text lane name equals lane's name. So here we take the lane name from the indexes and we simply display the lane name. Let's now run this. I'm not going much into which details of these functions because they're very basic drawing functions, and I'm using for this the Copilot. If you're not familiar with that, you can study the OpenCV basics. I teach everything in the community, but also from the OpenCV official documentation, you can learn everything you need about the OpenCV basic. Now you see, now I'm pausing the video. We have on the black car, it's C because it's on line C, so it's correct. The white car, it's on line D, so it's showing D. The other car, the last one, it's on line G, so it's showing G. When the car is outside of the lane, it's not displaying anything. So our detection inside the area is working very well, and now you see all the vehicles that are passing will tell you exactly what lane they're crossing. What can we do? Once we intercept this, we can save everything into a database. Let's now import the database. We're going to use a Mongo database. There are different types of databases. You might know SQL, which is the most popular, also the most old. Mongo database, it's my favorite because it gives you a lot of flexibility, there is less structure, and it works very well for such type of projects. And also it's very easy to scale. It's easy to integrate on the cloud. I really like this one. And so we're going with this one. Mongo database. I'm going to show you a very simple implementation that I created with this database. So let's connect to the database. DB equals Mongo database. We need to connect the database. We have connection string. Here we have MongoDB. This is the localhost database 27017. And then we can give a name to this database. Let's call this CV lane counting. And then collection name equals traffic analysis. So all the information will be stored in this specific database, CV lane counting, in the collection, or let's say table, traffic analysis. We have now implemented the database. What we do now, go on where we get the information that we want. So what we're doing here, we are check if the center box is of the box is in any lane. Right here, we understand when the vehicle is crossing the lane. When a vehicle is crossing the lane, we want to store the information into the database. So we record the vehicle into the database. So we have record ID. How do we get the vehicle ID? We have here a univocal ID of each vehicle. And so we have vehicle ID. Let's just copy this object ID. And then we have the lane name. We have already a lane name right here. And now we can create a record. And it is nothing more than a dictionary, because the MongoDB database, that's the nice thing, it will take dictionary format. We have vehicle ID, we have the vehicle ID, lane, and then we can put either the index or we can put lane name. Let's put lane name. Or class ID, now I have a single class ID for all of them, so we don't need this. And we can put a timestamp. If we're working with videos, the timestamp will be the timestamp of the video, which will be it starts from 0 from when the video begins, and then on each frame it will add a specific value based on how many frames the video have and so on. If you're working live, the timestamp will be the timestamp of that you have now, so the specific time that you have now. For simplicity, we'll go with the OpenCV one, but you get the point of what you have to do with this. We have the record, and now we have just to database insert record, just this. Now let's run this one. Now this is running, and in real time it's storing information into the database. You see insert a document with ID, and right here from the MongoDB Compass we can have a quick look at the database. We have traffic analysis, and here everything is stored inside. One last thing that we have to do, since each time on each frame, if the vehicle is inside, it's again saving it multiple times. We want to avoid that. Once it gets inside and we save it, let's stop saving it. We could do this in two ways. Either upsert the vehicles, find this into the database, and if it's there already, then don't save it. This will take a lot of resources. Instead, we can do it more simply. Temp vehicle records. So temporary, we save the ID, vehicles recorded, and if it's recorded, so once we insert the record, we also vehicle recorded, we add vehicle ID, so that if the vehicle ID is already stored, we don't need to save that again into the database. If vehicle ID is not in vehicle recorded, then we store it. As simple as that. Let's have a quick look on how accurate this is. I now empty the database. Let's run again our project, and then we double check what we see on the screen with what we get stored into the database. We see this, we have a vehicle 1, ID 1 is A, B, C on lane C, vehicle 3 is on lane D. So traffic analysis, we have vehicle 1 lane C, vehicle 3 lane D, and then now we have all the other vehicles coming. So if I update the database, I can see all the IDs. And then we have the timestamp right here with the specific time so that we know on this specific hour what vehicle were in that location and so on. And just this basic information will allow you to create a very advanced report, because you can intersect, manipulate this information as you need to extract it for your specific project. I hope that everything was clear. I know I went very fast. Let me know if you like this style or if you prefer that I go slower, but I wanted to give you as much information in a very short time. Let me know if you want similar project or any other things related to building more complex project or software structure. I'm always open to see feedback, and based on what I receive, I build the next videos. This is all for now. See you in the next one.